Alright, this is a video to help you find simplest form, or essentially simplify square root or radical expressions. There are three things that we want to make sure of when we're simplifying radical expressions. We're not done until no perfect square factor other than 1 is in the radicand. So things like 18, where we've got a 2 and a 3 and another 3 and some other, whatever else might be in there, need to be removed. Anything that's in there twice, and we'll show you why that is, needs to be taken out. No fractions can be in the radicand. So this middle example where we have 16 over y squared would also be an issue. And no radicals appear in the denominator of a fraction, or essentially when we take that square root of a fraction, because by rule we can split that into two square roots, top and bottom. What we're going to do is just hope that all the square roots are off of the bottom. And in this video, all the square roots will cancel nicely. You're going to need to watch a future video if they don't. Okay, and that one's all about rationalizing the denominator, as we say. So you might want to look to the day 3 video. All right. To start us off with, again, we've got the square root of 18 times x to the third. Basically, we have a rule, much like the division rule, that if things are multiplied underneath a square root, we can separate them. So if I think about 18 as being the square root of 9 times the square root of 2, that means I can break that into two parts. I can also do the same thing with my x to the third. That's really an x squared with a third x in there. And in that case, anywhere that I've got a perfect square, or essentially since 9 is 3 squared, the square root of 9 is 3. The square root of 2 I can't do anything about because that's a single number. But again, x squared is a perfect square, so I can take that outside. Get it outside of the root. I've taken the square root. But again, I can't take the square root of x because it's x to the first. Well, anything on the outside, we could just reorder. We're just multiplying. And anything left underneath is also going to be left inside. That is how simple it is to simplify a square root. With division, it's the same idea. The first thing we're going to do is think about square rooting the top. And then we're going to think about taking that radical or that square root of the bottom. Well, the nice part for us here is 16 is a perfect square. Again, we could break it down. We can make multiple parts there. But the square root of 16, I already know, is 4. The square root of y squared, on the other hand, is just y. And since there aren't any square roots left, that's going to be my best answer. Sorry about the crazy 4 on the top there. But 4 divided by y would be a good final answer. Now, what do we do when there's multiple things going on? One idea is just to put it all together first. Let's call that the square root of 48. Now 48 is a pretty large number. I don't want to break it down like I did 18 because I'm not quite sure what all is inside of it. So we've got a couple of options. We could make a factor ladder, or we could do a factor tree. I typically do factor trees, so I'm going to take 48 and I'm going to split it up. I know again that it was a 6 and an 8. I also know 6 is a 2 and a 3. Anytime I get a prime number, I'm going to circle that. Those are the leaves of my factor tree. So again, 8 could be broken into a 2 and a 4, and 4 can be broken into another couple of 2's. Realize that each one of those numbers is technically underneath that square root. So what we figured out is we actually have, if we consider the couple of 2's over here, and then again the couple of 2's right there, what we actually have is the square root of 2 squared, another square root of 2 squared, and the square root of 3, that other leftover leaf. I'm not worried about the other numbers because again they were broken down into the leaves. Well, that means that I've got the square root of 2 squared, or a 2, multiplied by again the square root of 2 squared, and a square root of 3 that again I can't do much about. With a little bit of simplifying, 2 times 2 is 4, and 4 root 3 would be the simplest form, as we say. No perfect square, these 2 squares or those 4's essentially were taken out. No fractions, such as the one in the middle again. And again, no radicals appear in the denominator of the fraction. That radical that used to be down here on the y squared in the middle example is now just a y. So tell you what, here are 4 different examples. If you'd like a challenge, go ahead and attempt these 4 by pausing the video now and filling out the questions. I'll fill in the answers one by one and walk you through my steps. All right, the first example is all filled in for you. Basically, I took the 75. Again, I did my factor tree. I broke it into a 25 and a 3. Then 25 breaks into a couple of 5s. Again, any pair of numbers is essentially the square root of 5 times the square root of 5, or just 5. So that 5 ends up on the outside of the square root. Again, the square root of x squared also ended up on the outside of the root. That's just an x. And then the leftover, that 3, didn't have a partner. It's left behind. So it's going to be left underneath that square root. All right, I'm going to pause the video again, and I'm going to fill in the steps. Feel free to try the next examples. All right, in the upper right here, we had a 72. I went ahead and split that into a 2 and a 36. Now, I noticed that 36 is a perfect square of its own. So I broke it into a 6 and a 6, and I actually stopped there. I could consider these sort of leaves, because again, the minute that I've got partners, the square root of 6 times the square root of 6, then I know that's going to come out to a 6. If you want to break down those 6s into a couple of 2s and a couple of 3s, you can do that. You're going to end up putting those 2s and 3s back together and forming that 6 on the outside. Similarly, I did that down here on the lower left. 2 times 90 was 180. I broke that into a 9 and a 20. A 20 was a 4 and a 5. Well, 9 is a couple of 3s, so I put that 3 on the outside of my square root. A couple of 2s, again, a pair of 2s, also goes on the outside. And that leftover 5 is going to be left underneath. Well, 3 times 2 on the outside will become 6. And the square root of 5, essentially, can't do anything about that. We're just going to leave that behind. Again, the goal with simplifying is not to get decimal values. We're not just typing these in the calculator. We're trying to simplify without rounding. Remove anything you can from under the radicand, but do not round. All right, pause the video one more time. I'm going to go ahead and attempt this last problem down here at the lower right. It seems to have a lot going on, but let's see what we come up with. All right, here we go. We've got everything down here at the bottom. I've broken this into all of its parts. First, I broke up the division. Then I realized I had multiple things multiplied up top. So I've got a square root of 36, a square root of x to the third, a square root of 49, and a square root of y to the 12th. The square root of 36 is 6, and the square root of 49 is 7. So we can just handle the numbers quick and easy. We didn't need to do any factor trees. Again, perfect squares, pretty easy to take the square root of. Square root of x to the third can again be thought of as 2 different x's and then a third one. So the square root of x squared can just become x, and that leftover x is the only thing left underneath the root. On the bottom, again, we've got that y to the 12th. Well, if you think about it, using our exponent rules, remember power to a power we would multiply. Y to the 6th squared, right? Creating a perfect square. Y to the 6th squared would essentially be the same thing as y to the 12th. Well, if the square root cancels with that 2, cancels the square, then we end up with a y to the 6th. Again, we also could have broken that up like we did on top into 6 different square root of y squareds. But again, 6y's all multiplied together then would end up being y to the 6th, and you'd still end up with the right answer. I hope that helps you with simplifying square roots. If you have any questions, make sure you ask your teacher. Otherwise, good luck and have fun.